I'm going to start this with a couple of questions. Has anyone in the room fitted a gas meter before? A few around the room. How tight did you do the nuts up?
Back a long time.
There we go. And if you were looking to find out how tight they should have been done up, any idea where we might find that information?
Until it's gas tight.
Sorry?
Until it's gas tight.
Well, yeah, testing can prove that. Right. Okay, so that to just get us kicked off. Thanks for the introduction. My name's Sam. I'm the Technical Manager for Energy Metering Solutions. I've been working in gas metering since late 2016. And when I entered the field, it became pretty apparent very fast that tooling and the way we install this equipment hasn't really changed sort of ever, really. We're still using some pretty agricultural kit to get these installed. So the gas meter spanner set was essentially born. We've come up with a product that can speed up installation, make installation safer, and give you a way you can actually reference your tightening torque and the force you're applying to the seal. So, eventually, this is what was come up with. Just to go through a tiny bit of background on installations we found. We can see some of the older tools that were being used and are still being used out in the field today. So we got up here is a aluminium 36-inch pipe wrench, about yay long. Reasonably light because it's aluminium. Some of these are drop forged, heavy iron tools, which aren't very handy when you're operating through a hole this big with all this length. So here we have a quick, absolutely very fast, hopefully without any audio, demonstration of the kit in use. What I'm going to do is just undo a couple of these unions so that you can see. Oh, blimey, that is tight. There we go. Oh, blimey. We were doing a little bit of research into actually how tight we could do these with the set as a bit of an investigation into over tightening. So hence how tight those were. Right, so the video is going to play and I'm just going to run through the same process with a bit of commentary. Superb. So anyone at the back, we can still see that. With our ratchet set, can work all the way around. When you sight the fitting, you can run the whole way around, as opposed to a longer tool, you might get possibly a quarter turn here before you're taking it back off, resighting, going again. So we can get this done up in a couple of goes. Let it go through the hole. We can see the relative speed and ease with which that's installed in comparison to a much larger tool. Let's get off of that face there. Now somehow I've ended up with completely the wrong presentation up here. So I'm going to talk about this whole thing for a little while. British Standard 746 was first conceived in 1937, the first specification for gas meter unions and adapters. 1937, my mistake. So since 1937, there doesn't seem to have been any effort to create a tool specifically for the job. I hunted high and low for something else, anything else, couldn't be found. So eventually, the decision was taken, we were looking to have something made ourselves. Found our manufacturing partner, Morn Industries, who helped us develop the design, very, very helpful with material selection, hardening, and have been fantastic, really. Their input has been brilliant towards the way we developed the tool. Initially, I was along the idea of a double-ended spanner, more typical like a standard open-ended spanner, with some lugs to attach an extra drive to give you more leverage when things had been over-tightened. Unfortunately, we decided the weight of that, the physical cumbersome ability, we're trying to keep things lightweight and easy to use. That was going to end up being quite heavy and unmanageable, so we switched to the single spanner heads with a ratchet drive, which allowed us to find a sighting on a nut wherever it was sighted. The design of the jaw opening allows us to get around octagonal and hexagonal fittings and adapters. And there's 14 different sizes that have been matched to suit every adapter in British Standard 746, the latest release of which is 2014. Back to my questions at the start. Tightening. How would you figure out how much you want to tighten this gas meter to? There wasn't loads available, so it was back to referencing the standard, BS746. And it actually emerged that whilst there were no recommended tightening torques as such for installers, the testing specification for the joint itself, as to prove whether the elastomeric washers were suitable, making a correct seal, does supply 2 torque settings. So during the testing of whatever size fitting, 2 inch, 1.5 inch, 1.25 inch, and down to 1 inch for domestic meters, the joint will be made, an initial tightening torque will be applied. The fitting is then put through a series of temperature cycles, simulating real-world field conditions where you will get temperature rises, temperature falls, all that contribute to expansion and contraction of the fittings, the joint, and the rubber inside itself, after which period it's also tested for leakage and then checked for release torque. So over the life of this fitting and this elastomeric washer, it should still be at a set tightness. The rubber should retain a certain amount of elasticity to continue to take up thermal expansion. And so you're then given a release torque for that. So that was all we really had to go on. Now we had some figures to work with. They weren't defined as finishing figures as far as a recommended torque. They were very tight, some of these torque settings for the initial test. So we thought, well, we need to make sure our new tool is capable of achieving that torque, exceeding that torque, and carrying on to not fail in use as a safety case as much of anything else, as well as reputation of the equipment, replacements, what have you. So the initial design was a 6mm plate, case hardened steel, and we went around some destructive testing. The 52mm variant, this one here, which would fit, if any of you know, a U16 gas meter, the 1.25 inch outlet unions on that meter. The original design was 6mm thick plate, and this one broke at 135 Newton meters, which is a fair bit. It's hard to give you a decent equation of how, idea of how much force that really is, but it's no small amount. The larger variants, the 80 and the 86 millimeter, broke at 190 Newton meters. The tightening torque for the test, the initial torque on a 2-inch meter union such as it is 100 Newton meters. This was proven to break at 190, so we wanted to increase that safety factor to over 2, so the decision was made to up the plate thickness from 6 to 8 millimeters. Saw no reason to carry on and do further destructive testing on this thickness, as it was well in excess of what we would expect to see in reasonable use. You know, tool abuse is a thing, but we're trying to avoid that situation too, and with an 8 millimeter plate, we don't believe there should be any breakages, no matter how much you misuse the tool. So through the design process, a couple of modifications were made. The initial across flat dimensions we found and that we took from the standard there are some engineering tolerances on the fittings themselves. So we found that 85 millimeters was loose on some, tight on others, of the exact same union, the exact same fitting, just a manufacturing different tolerance on the fitting. So 3 sizes had to be slightly overground, adjusted to accommodate a little bit of variation in the fitting manufacture. It was also requested by a subcontractor that we come up with a hexagonal key, which would go down into this fitting here. So when I split that, we had a male adapter into the valve with a British Standard 746 male thread at the top to make our connection. Inside of this, there is a hexagonal profile. Previously, again, the approach would have been a tooth tool, scratch, dent, damage that piece of brass. Probably would never be able to get it out again after that, unless you took this whole fitting off and ruined it. It would be for the bin afterwards, not worth using. So this can then get down into the fitting, we tighten that into a valve without damaging any of the external brass. We've already mentioned the changeover to a ratchet, and then it was a case of packaging it and doing some more research into the standard. So that was, and you see us at this stage now. Also looked at this kit covering a full industrial and commercial meter fitters tool set, but with the domestic smart meter rollout in place, there is also a lot of new fitters, maybe who haven't developed engineering feel, all that stuff you gain from experience on site, that we thought they may need some guidance, and with the domestic set, we've scaled this down to meet a smaller range of meters that you would typically expect to see in houses, while excluding the larger sizes. That gives you a smaller cost. Hopefully that can make it more accessible to this smart meter market. And if you couple that up with a small inline torque adapter, which is in the pocket of my jacket up there, you can then give these torques that we've found in the standard to the engineers. Your new, inexperienced fitters can be measuring what they're applying until they develop genuine, experienced engineers' feel. And hopefully that way we can avoid. I struggled to find figures. I did ask everybody I could how many gas leaks on meters we have had since we started rolling out smart meters. Nobody wanted to give their figures away. But I imagine it's quite a few. So with that in mind, every piece of information that can be given to new engineers, new fitters, decreases the risk of leakage, gas off time, inconvenience to customers, and the general bad rap that the gas industry seems to get when we're trying to roll out a project for good. So hopefully, with this tool and the correct application, we should be able to see a lot less gas leaks out in the world in the future, and a lot less bruised knuckles and inconvenience from the previous set of tooling. Over to you, judges.
Lovely.
Thanks, Sam. Well done. Sam, I'm interested in how it's developing going forward now, and your thoughts around that. You know, looks a great product to me, and I wish I had it when, you know, I keep banging my knuckles. So how do you see that going forward? And more importantly, how do you see your part in that?
Well, my part going forward, really, I have seen this project from start to finish, with mentorship from and support from various people within my company. Really, what I would like to do now is get this in the hands of engineers. It's been sent out to our subcontractors. We've done a lot of field testing. All the results were very positive. But really, I would like to see this in use in the field, because I think once it's recognised what we're not doing correctly by sitting back on the we've always done it this way, the tighter the better, that on the ground fitters attitude that you do still see and is being passed on to new fitters, if we can change the way people are thinking, change the way people want to install, they want to measure it, they want to know they're doing it up correctly, we can improve safety, improve gas supply and the gas industry for the end user. Essentially, they're the ones who suffer when they have a leak, they have to call it in, they have to stay at home all day to wait for the fix. And it gives the gas industry a bad name, and I think we can do a lot more.
Sam, have you done a cost-benefit analysis on the speed of implementation, the reduction of risks, the call-outs?
For
Do you know how all this stacks up?
For any potential user of
Yeah.
this equipment.
How would you go out and sell it? What's the sales pitch ultimately? Is it 10% quicker, 50% quicker, 50% safer?
Yeah, well, we've seen in the short video, I managed to get that meter uncoupled, a mock check, and recoupled in a minute. Time saving is a bonus if you can work speedily, but safety is more important. So again, without leak figures as a direct result of gas meter exchanges, it's very difficult to make a projection on the improvement we could have. The best way I could make a comparison, and this was in my original presentation, I don't know where it's gone. The short one appeared up on there. But we were coming across a lot of meters where initially it had been over-tightened, the installation had been there 15 or 20 years, the washer then become harder, brittle, wasn't as elastic, taking up the space. You have small gaps there, condensation accumulated, and you get rust, corrosion on the fittings. And when that does eventually leak, you can't just go and change the washer. It's seized, it's corroded shut, and one in particular, I had to get a rather large Stilson pipe wrench on there, and the outlet connection of the meter just sheared, turned. So by tightening correctly, keeping the elasticity in the washer, we should reduce water ingress into fittings so that when leaks do occur, they can be repaired quicker, more effectively, rather than having to cut out an entire installation. So speed of future repairs and a lack of future leakage was the objective, really.
So I think it's a great product. I think the answer to your question is somewhere between 3 and 5%, but I can give you it accurately at some point. 3 to 5% of smart meter installations have a leak associated with them.
That high?
After
wow.
that. Which is actually lower than we forecast when we started the process. But a lot of the benefit, I think, you know, the bit that you don't get stood on the stage there is these things are in some very tight spaces.
Yeah.
And having a flexibility in the product, I think, works really well. Do you have a thought as to, you know, clearly this is of benefit to your business? Do you have that thought of the rollout into the wider installation community?
Yeah, I mean, it was initially for us. I needed something to work with that was better than what I had, but having seen the benefit and gone through the development and the feedback from everyone who's used it, and in fact everyone who's seen it. If I'm out attending a gas leak, for instance, the FCO next to me, I open that, wow, where did you get that? That's fantastic. That does exactly what I want. So yeah, we do now have an avenue for production and sales. I would hope to see this appearing in the field.
Time. Thank you, Sam.
Thank you.